Hi class, short lesson today on using inductive reasoning in continuing a number pattern and then also writing rules for arithmetic sequences. Okay, this is lesson 5-7 in the notes as well as in your textbook. First thing you need to learn, I would write down a great definition, great flashcard question, is the standard setup for an arithmetic sequence. Okay, notice we're using function notation here. Let me get my magic pen out. We're using function notation. Okay, so a of n is our function notation. And a of n is going to equal a plus quantity n minus 1, closed quantity, times d, which is the common difference. Okay, so a is the first term here, n is the term number, and then d is a common difference. So let's look at a few definitions here. We have a sequence is just a number pattern, and then we have a term of a sequence. Each number in a sequence, okay, is a term. So like the first number in the sequence is the first term, the second number is the second term, and so on. And then an arithmetic sequence is a kind of number sequence formed by adding a fixed number each time. So I'm going to start out at one number and then I'm going to add the same number over and over and over again. And then we have a common difference, and the common difference is a number that's added to the previous term in order to get the new number. Inductive reasoning, when I use that term inductive reasoning, it's just making conclusions based on the patterns you observe. And most of you are pretty good at inferring things from the information given. And then we have conjecture, which is a conclusion you reach by inductive reasoning. So if you can think of maybe a science connection between hypothesis and making a conclusion, making a concluding statement. All right, let's look at our first example here, and you want to use inductive reasoning to describe the pattern and then find the next two numbers. So you see here we go from 1 to 3 and then 3 to 9. Find the next two numbers in the number pattern and describe what's happening. I would say I'm multiplying by 3 each time. Do you see that? 1 times 3 is 3. 3 times 3 is 9. So then the next two numbers, 9 times 3 is 27. And then 27 times 3, 81. Did you get that without using your calculator? Great job. Let's look at the next example here. We have 1 to 9, and then 9 to 25, and then 25 to 49. This one, I don't know if you recognize, but these are all your perfect squares. 1 squared is 1, your odd perfect squares. 3 squared is 9, 5 squared is 25, 7 squared is 49. So now we're looking at 9 squared, which is going to be the next number in the pattern, which is 81, and then 11 squared is 121. Oh, forgot my squared sign there. Okay, moving on, moving right ahead here. Okay, so here we have an arithmetic sequence. We're finding the common difference here first, and then we can write arithmetic sequences from that. Notice our first term here is 5, and what's happening is we are going down by 3 each time. So we can see that common difference as a minus 3. Notice in B, we're going up by 3 each time. So our common difference is a positive 3. Let's move on, and here we have an arithmetic sequence. You know what? Before we go on, let's write an arithmetic sequence for this one. Go back to your formula, and remember we have a n equals, what letter did we use? A was our starting value, right? A was our starting value. Sorry, I forgot which letter we were using. A is our starting value plus, and then we have n minus 1 times the common difference, which we used as d. So in this situation, you could write your own arithmetic sequence and figure out what the 100th term in this pattern is going to be. So we can write our arithmetic sequence of a of n equals our starting value of 8 plus, that's the first number, okay? And notice we have the n minus 1 because we're already taking care of the first number, the first term in the pattern over here. So we're going to, we don't need, that's why we need the n minus the 1. And then we're going to multiply that by the common difference of 3. So now we have a great equation that I could ask you what the 99th term in this arithmetic sequence was, and you could tell me that by plugging in 99 for n, subtracting 1, multiplying by 3, and adding 8, and that will give you the number of that term. Okay, so let's look here. So we have a of n equals 15 plus the quantity n minus 1, closed quantity, times 5. Okay, so just look at the pieces of information. Our first term is going to be 15. Our common difference is going to be 5. So we're going to be going up by 5 all the time. So 15, 20, 25, 30, and so on. But who wants to sit here and do that when we only need the first term, the fifth term, and the 10th term? So what we can do is we can plug in 1 for the first term. Okay, we plug in 1, we do the math here, and we get 15. It's kind of obvious because we know where the first term is found in our equation. But then looking at the fifth term, you plug in 5, and so you take the 5 minus the 1, which you get 4, multiply it by 5, and add 15, and you get 35. And then to find the 10th term, you're going to do the same thing again, plugging in 10 for the n, subtracting 1, which you get 9, times 5 is 45, plus 15 is going to give you the 10th term of 60. How are we doing on that? Great job. That's it for arithmetic sequence. Again, you just want to memorize the formula. We'll go back to the main page here, which is a of n is equal to the first term, which is a, plus the product of the term number, which is n minus 1, multiplied by the common difference. This is arithmetic sequence. Great job. I'll see you tomorrow in class.